Hello, my dear students. Today we're going to solve question number 3, a problem about inclined plane. So here we have 112 kilogram wooden crate on frictionless inclined plane, so we don't have a friction. The angle is 42 degree, is connected by a rope over a frictionless pulley to a 112 kilogram block hanging vertically as shown in the figure. This should be 150. Anyway, neglect the mass of the rope and the pulley. What do we need? This actually, it's one of the EMSAT question. We need to calculate the downhill acceleration of the wooden box. Okay. Now, as usual, when we have inclined, when we have a question that is related to forces or in Newton's law, the first step is to draw a free body diagram, all the forces acting on the object. And here we have two objects. We have the first object, which is the 112 kilogram crate, and the other one, which is this box hanging 150 kilogram. We'll take each one alone by itself and draw all the forces acting in each one separately. So let's start with the crate. First, I have force of gravity down, the weight down. How can I calculate the weight? It's mass times free fall acceleration. So M is 112 times 9.81, and this will equal 1098.72 in Newton. On an inclined plane, the motion of object is typically along the ramp. It's either upward, either sliding down, or moving up. Now, to simplify the analysis, always we align our coordinate axis with the inclined plane. So this is the inclined plane. So this will be our x-axis always. And perpendicular to this one up here, this is y-axis. In y-axis, perpendicular to the plane, we have the normal force. So from here, this is Fn, the normal force is perpendicular to the surface, perpendicular. And the other force here, we have tension. So here we have Ft. Fg, we need to break it down to x and y components. So if we extend the y-axis here, so this is Fg in y direction, this angle. So Fg is going to be cosine the angle because it's adjacent to the angle. Extend the x direction along the incline. This will be the x component. So the x component of the weight is always parallel to the inclined plane and acts downward along the slope. So here, this one, I have Fg sine. If this one cosine, this one will be sine because the triangle here is similar to the big triangle of the inclined surface. Okay, so let's take the first object, which the first mass, which is 112 kilogram. And again, we're going to make x and y. So here we have x and we have y. The object is moving in this direction. So forces in the same direction of motion will be positive. So Ft, the tension force, is positive. And this one here, Fg sine the angle, will be negative. Okay, so we have motion, so it's going to be Newton's second law. All the forces acting in x direction will equal mass times the acceleration in x direction. So we'll have Ft minus Fg sine the angle. Fg, it's 1098.75 sine. Okay, let's go. little bit up, and sine 42, this will equal MA. Mass times the free fall, the acceleration. Mass is 112 times A. So this will be FT. If we calculate this one, it will be 735.2 equals 11A. And we can call this one equation 1. So let's go to y direction. We said we have to make a table x and y. I'm going to do it down. Y direction, down. So in y direction, since since I have frictionless surface, I don't need to calculate Fn. In y direction, Fn equals Fg cosine the angle. But since no friction, we can ignore this one. We'll ignore it. If we have a friction and the direction of motion is along the incline, the friction will be always opposite to the direction of motion. Since we have no friction, we can ignore calculating the value of the normal force. Let's go now to the second object. The second object, which is 120. And this one, I'm going to use different color. Let's do this one. Here I have force of gravity down, and I have tension force up, and the object is going to move in this direction. So forces in the same direction of motion is positive. This one is positive, and this one, tension, will be negative. Okay. So let's move all of these up. Okay. So second object now, which is 150 kilogram. Okay, this is y direction. All the forces in y direction equals MA. Okay, now remember, Fg is positive, Ft is negative, so it will be Fg minus Ft equals MA. Okay. Now, the value of Fg for this object, we need to find it out first before we solve the question. Fg is mass of the object times free fall acceleration, so m times g minus Ft equals 150 times A. M is 150, so this one will be 150 times 9.81. 150 times 9.81. If we calculate this one, we should get 1471.5 minus Ft equals 150A, and this is equation 2. Now we have two equations with two unknown, which is the tension in the rope. Since we have the same rope, it means same tension force, and acceleration. And equation number one, we have Ft and we have acceleration. So we need to solve these equations simultaneously. We can use either substitution or elimination. To use the elimination, one of the variable should be same but having opposite signs. So I have Ft here positive, and down I have Ft negative, so I can add these two equations to get rid of the tension force. So here we're going to write, I'm going to add equation 1 and 2. So we're adding, okay, add 1 and 2. Add equation 1 and equation 2. Now equation 1 will be, just I'm going to rewrite it, ft minus 735.2 equals 112 acceleration, and the other one 1471.5 minus tension equals 150A. Add. So this one is cancelled out with this. 1471 minus 731.2, you should get 736.32 equals 112 plus 150. If you add these, you should get 262 times A. I need the value of the acceleration, divide both sides by 262 by 262, and you should get the acceleration equals 200.81 meter per second square. That's it.